Okay, there's a bit of jargon involved with probability, and one term that you need to be aware of is mutually exclusive or mutually exclusive events. So mutually exclusive events have no outcomes in common. And probably the best way to explain what no outcomes in common mean is to do a quick little example. So we have a pack of cards, and you should be very familiar with what's in a pack of cards. 52 in a standard pack, 4 different suits, 13 cards of each, and 4 different spades, clubs, diamonds, hearts. So there's two suits of red, 2 suits of black, etc. So you should be very familiar with what's in a pack of cards. And say you have a pack of cards and you pick one card randomly from the deck. So the probability of an ace, given that there are 4 aces, or a 7, ace or a 7 are what we call mutually exclusive events. Basically it means that you can't have a card that's both an ace and a 7. There's nothing in common between an ace and a 7, they're quite distinct. And the addition rule for mutually exclusive events, so we'll talk about the addition rule now. Let's call the addition rule for the obvious reason that you add. Probability of A or B. Or is a key word in probability. It means add. Probability of A or B equals the probability of A plus the probability of B. And A and B must be mutually exclusive. So if we want to work this probability out, we were before, the probability of an ace or a 7 equals the probability of an ace plus the probability that it's a 7. We've determined that these two are mutually exclusive. 4 aces in a pack. Total number of outcomes, total number of cards in a pack is 52. Plus probability that's a 7. How many 7s in a pack? 4 as well. Over 52 equals 8 over 52. And once again, always try and cancel down your fractions. So 4 goes into top and bottom. So 2 over 13. So they were mutually exclusive events. Let's have a look at, go a step further, of events that are not mutually exclusive. So we want the probability, it's an ace or a heart. Okay, think about a pack of cards, the aces and the hearts. There are 4 aces and there are 13 hearts. And are these two mutually exclusive? No, they're not, because you can have a card that's both an ace and a heart, i.e. the ace of hearts. So ace and heart are not mutually exclusive. Due to the fact that you've got the ace of hearts. So the addition rule that we've used up above here, that for probability of A or B is equal to probability of A plus probability of B, is not going to work down here, because this is only going to occur when A and B are mutually exclusive. So the addition rule has to be changed. Probability of A or B equals the probability of A, now or, we said as add, plus the probability of B, same as the rule we had up above, but it is different in the fact that we've got to take into account that we've got some overlap, that the property of an ace and a heart can be shared. There is some commonality there. So it'll be the probability of A plus the probability of B, just like up above, but minus the probability that it is A and B. Okay, so how do we work out this one here, probability of an ace or a heart? So we've got probability ace or a heart. The events are not mutually exclusive, so it'll be the probability of an ace plus the probability it's a heart minus the probability it's an ace and a heart. Okay, probability of ace is the same as before. There are 4 aces in a pack, so 4 on 52 plus. Hearts, how many hearts are there in a pack? There are 13 hearts in a pack over 52 minus probability of an ace and a heart. Now how many cards are in a pack are both an ace and a heart? Well, that's just one, which is the ace of hearts, so it'll be 1 over 52. And I think if we add 4, 13 is 17, minus 1 is 16 on 52. And I think 4 will go into top and bottom, so we get 4 over 13. So that's the probability that you're going to get an ace or a heart. They are not mutually exclusive, and so we've got to subtract the probability that they are both. So and normally implies that you multiply, and or is add.